Okay, so welcome back. So the last video cut off, and so we were taking 1.15 to the 13th power, and we should have gotten 6.15 and a bunch of other things. And then when we multiply that by 2,000, not 2,000, 2 million, we get 12,305,575 and 24 cents. So back here, I've written up here P of 13. So this is for ComputerFest. They're at 13 years. They make 12,305,000 and a bunch of other things. So I guess I could write all that down. 305,575. That's good enough. Okay? So, at year 13, ComputerFest surpasses Calcurama in terms of the amount of money that they're making and their overall profit. So they start off slow, they're making less, they start off with less money, and in the beginning it looks like they'll never catch up. But after the 13th year, they have caught up and now they are making more money. So in the end, ComputerFest will make more money. Okay, let's go on to the magic of compound interest. So let's read about Mama Big Bucks. She puts $20,000 in a bank savings account that pays 3% interest compounded annually. Now, compounded annually means that at the end of the first year, the bank pays Mama 3% of the 20,000. So they add $600. That's 3% of 20,000. They add 6,000 to the account. Mama leaves her original money, $20,000, and the interest, $600, in the account for a year. At the end of the second year, the bank will pay interest on the entire amount, which is $20,600. Since the bank is paying interest on a previous interest amount, this is called compound interest. So, we're going to create a model to represent how much Mama will make after T years. So let's do that. So this is very similar to what we did with Calcurama and ComputerFest. We've got that Mama is making 20,000. So we'll say F of T, since it's the time in the years. F of T equals, let's see, she starts with 20,000. And then she multiplies that 20,000 times the 3%. So that's 0.03%. All right. But it's the 0.03%, and then she adds it to her original amount, right? The 20,000 or whatever it was before that. So there's this adding of the previous one. And remember when we did the distributive property and we ended up with 1.15? Well, we're going to do the same thing. We're going to have 1.03 because it's always the original amount or the first amount or the previous amount. And then we're going to multiply that amount by 3% and then add it to the original. Okay, so we're going to say 20,000 times 1.03 to the T power, which means that each year we're multiplying by 1.03. All right, we start at 20,000 and then each year we multiply by 1.03. So now we just have to figure out how much she will make after 20 years. So if I go to my calculator and I say 1.03 to the 20th power is going to give me this 1.80, and I times that by 20,000. She will make $36,122.22. So we'll just round it to $36,122. So after 20 years, she will make 36 f of 20 equals 36,122. All right? So I spent a lot of time in the previous video showing how we kind of use the distributive property and going through the process of going from recursive to explicit to an exponential function and figuring out that our common ratio is going to be the 1.03. So I don't want to spend too much time going over it again. There is a formula that banks use that it's called the magic of compound interest. That's what people talk about, the magic of compound interest, because compound interest allows you to accelerate the amount of money that you make. There's two different types of interest. There's simple interest and compound interest. Simple interest is a linear function. Simple interest says you take your original amount, and that's called the principal, the amount that you start with, that you invest, and you make a certain percent of that principal every year. So if you make 5% of $20,000, then that's going to be, what is that going to be? I can't even tell you. $4,000, right? So it'll be not 4,000, 400. So 20,000 times 5% is $400. So that just means every year I get an additional $400. And so that's a linear function because I'm just adding 400 each time. But compound interest says I not only take the percentage of the principal, but I also take the percentage of the principal plus the interest from previous years. So my principal keeps changing. So the formula that we're going to use for this is amount is A of the money in the account after a certain number of years. So A equals P. P stands for the principal, which is the original amount of the investment, times 1 plus the annual interest rate. So you have to add 1 to it. That's the way that we get that added part from each term. 1 plus R, and the whole thing goes to the T power, meaning the time in years. So that is an exponential function, but it's very specific to interest rates, compound interest rates. All right, so we can use that little formula, A equals P times 1 plus R to the T power, where each thing represents. A is the total amount, but it could also be written as an exponential function, couldn't it? It's going to be f of x equals, P still needs to be the principal, right? Times 1 plus R to the x power. So I guess it's not really very different, but an exponential function has an a, and this is my a. It has a b, the 1 plus r is my b, and it has to the x power, that's your time. All right? Now, another way that we use compound functions, well, let's actually is using depreciation. So let's read about Mama Big Bucks buying a car. So she buys a car for $20,000 and it depreciates at a rate of 3% per year. At the end of the first year, the car loses 3% of its original value, so it's now worth $19,400. So now we've got a little bit of a different look here going on. Instead of adding, we're taking money away. So the way that we do that is we're going to do the exact same thing that we did with adding, but this time we're going to do some subtracting. So let's think about this. If Mama's car depreciates by 3%, that means it becomes worth less. All right, it's 3% less. So let's think about what if we had $20,000 and 3% of $20,000, that means that after the first year, she loses $600. So that's why at year zero, mhm, at year zero, she has 20,000. The car's worth 20,000. But after the first year, we're subtracting $600. So then it's worth 19,400. Now what happens next is that in the year two, it's not that we're taking $600 away again. We're taking 3% of the 19,400. So each time we take the first amount and we take 3% of that and subtract it. So the way that we write that is we can think about it this way. We can say that f of x is equal to the first amount, or we could say the principal, or the original amount of the car, times 1 minus the rate to the x power. All right? So when we think about it that way, we could say, well, if 3% of the car has to come, if 3% is how much it depreciates or is lost, then that means that 97% of the that's what's left. So when we say 1 minus 0.03, which would be the percentage, we end up with 0.97%, don't we? So in this situation for Mama, we could say that her car is going to be worth, let's see, we'll say f of x equals, her amount is 20,000 times 97%, because we're taking 97% of the 20,000, to the x power, and x representing the years. All right? So now we just have to find out how many years it will take for Mama's car to be worth less than $500. So then we want 500 to be, we want the car to be less than $500. So we got to figure out, to what power do we have to get 97 to? When we multiply it by 20, we end up with $500. So why don't you do a little bit of guessing and checking and see, using your calculator to see. I'd start with 10 years. How low is it at 10 years? And then maybe go with 15, 20, and see if you can find when you get to 500. Okay, so I did some of the work as well. So I did f of 10, and after 10 years, the car is still worth 14,748. I then did f of 15, and it went down 12,000, and I saw that it was going to take me a long time, especially by the time I got to f of 20, and it was still only 50% of the original price, 10,875. So then I decided if I got to get down to below 500, then I'm going to skip to 100 years. What happens after 100 years? F of 100. When I put in f of 100, I got 951. I'm getting closer now. I moved to f of 200, and 200 brought me down to like $45, so I knew that was too much. So then I did f of 150, and I got $207. So now I know I'm somewhere between 150 and 100. So the next thing I tried was 120. And when I did 120, I did 0.97 to the 120th power, and I multiplied that by 20,000. I got $517. So now I know I'm getting really close. So this time I'm going to try the 121st year, because I think by then I'll be below 517. So 0.97 times, not times, clear, 0.97 x to the y, 121 power. Oh my goodness. Let's try this again. 0.97 to the 121 power times 20,000 equals $501. Oh, turns out it was 122 years. Really unrealistic.